Hello everyone, I am Rinku Tade from AIML department and I will be taking you through today's lecture on DBMS. So let's get started. First of all, let's understand what is DBMS. DBMS is the software that manages the database and allowing users to create, store, manipulate and retrieve the data within it. And it acts as a bridge between users and the database, ensuring data integrity, consistencies and security. Examples of DBMS like MySQL, PostgreSQL, Oracle, etc. Now the next topic is database approach versus traditional file system. In the traditional file system, data is stored in separate files inside folders on your computer. Each program its own data. For example, one file for students, another for fees, and another for library records. But in a DBMS, all the data is stored in one centralized place and it is managed by DBMS softwares. This makes it easier to organize and retrieve information whenever we need it. Next is data redundancy. In the file system, you might find same data stored in multiple files, like a student's name appearing in both the library file and the exam file. This create a duplication. In a DBMS, the problem does not exist because the data is stored only once and other tables can link to it. So redundancy is reduced and consistency is maintained. Next is backup and recovery. The file system does not have an automatic way to back up your data. If you lose a file, it is usually gone unless you manually save a copy. But DBMS has built-in tools for backup and recovery. Even if there is a system crash, you can recover your data safely. Now the next is query processing. In the file system, if you want to find some specific information, like all the student who scored above 90 marks, you will have to open and search files manually. But in a DBMS, you can just write an SQL query and get the results instantly. That is a huge advantage. And next is consistency. In a file system, if you change a student's address in one file but forget to update it into another, so your data becomes inconsistent. But in a DBMS prevents that through something called normalization, which keeps data consistent across the database. Next is security. The file system have very basic security. Anyone with file access can open or edit it. But DBMS provide advanced security features like user rules, passwords, and access permissions. So only authorized users can access or modify sensitive information. Now the next is cost. Cost. The file system is cheaper because it does not require special software or hardware. However, a DBMS is more expensive and gives you such a better performance and reliability. Now the next topic is advantages of database systems. The first is data security. DBMS keeps our data safe from unauthorized access using things like password, access control and encryption. Now the next is data integrity and consistencies. It makes sure that all the data stored in the database is accurate and consistent and it prevents from duplicate or wrong entries. Next is reduced data redundancy. Since all the data is stored in one central location, we don't need to keep multiple copies of the same information. This saves spaces and avoids confusions. Next is data sharing. Data sharing is another advantage. Multiple users can access and work with the same data at the same time without any conflict. It also provides a backup and recovery, which means if the system fails, the DBMS can automatically restore the data. Coming to scalability, DBMS can easily handle a large amount of data and can grow with the organization's needs without slowing down. And finally, data independence. Data independence is that the structure of the database can be changed without affecting the applications. So overall, DBMS gives us security, consistency, efficiency, and flexibility, making it a powerful system for managing modern data. Now the next topic is data models. Data models is basically a blueprint that shows how data is organized, structured, and connected inside a database. It helps us understand how different pieces of data relate to each other, just like a map, help us to see how different places are connected. There are several common types of data models, like first is hierarchical model, network model, relational model, relationship model, and object-oriented model. Each has its own way of representing data and relationship. First, we have the hierarchical model. It organizes the data in tree-like structure, where each child has only one parent. For example, in an organization chart, one manager can have many employees, but each employee reports to only one manager. Next is network model. This model allows manager to manage relationships between records. For example, a student can enroll in multiple courses and each course can have multiple students. Then comes to relational model, the most widely used model today. And it stores data in tables with rows and columns, and relationships are built using keys. For example, a student table and a courses table can be connected through a student ID. The entity relationship model (ER model) represents data visually using entities, attributes, and relationships. For example, a student entity can have attributes like name, roll number, and a relationship within a course entity. Lastly, the object-oriented model stores data as objects just like in programming. For example, an object like car can have properties such as color and speed and methods like start and stop. So in short, each model represents data in a different way, but all of them aim to organize information efficiently within a database. It defines how data will be organized, what tables will exist, and what relationship they will have, and what rules or constraints will apply. Now see schemas. Schema shows the structure of the database, not the actual data. Schemas are created during the database design phase. For changing a schema requires a carefully planning because it affects the entire database structure. Instance Instance refers to the actual data stored in the database. So while the schema defines the structure, the instance shows the records present in the database. For example, in a student database, the schema defines students table and its columns, and the instance contains the actual list of students and their details. Instances are dynamic, meaning they change frequently as data is added, updated, or deleted. They reflect the real time operations happening in the system. Now, the next topic is data independence. We can change the structure of the database at one level without affecting the next higher level. This helps keeps our data flexible, so even if we modify how data is stored or is structured and the application still work perfectly. There are two types of data independence. First is physical data independence. It means we can change how data is stored physically. For example, upgrading from a hard disk to an SSD without changing the database structure or the application that uses it. The second type is logical data independence. This means we can change the logical structure of the database, like adding a new column, merging two tables, splitting one table into two without affecting the user's application that access the data. Now the next topic is database languages. There are different types of commands which are used to define, manage, and control data in a database. Database languages help us to communicate with the database and perform various operations. There are mainly four types of database languages. First is the DDL, data definition language, data manipulation language, transaction control language, data control language. Let's go. Let's go through each one briefly. First, we have DDL, data definition language. This one is used to define the structure of the database, like creating or modifying tables. Common commands this includes add create table, alter table, drop table. So basically, DDL helps us to design the database structure. Next is DML, data manipulation language. This is used to work with the actual data inside those tables, retrieving, inserting, updating, or deleting records. Some commands like select, insert, update, delete comes under the DML. In short, DML helps us to manage data itself. Then comes to DCL, data control language. DCL manages user permissions and control access to the database. For example, grant is used to give permission and revoke is used to take it back. This helps keeps the data safe and secure. Finally, we have TCL, transaction control language. It is used to manage transactions. It making sure data stays consistent and accurate when multiple changes happen together. The most common commands are commit. Commit is used to save the changes, and rollback. Rollback is used to undo them if something goes wrong. So in short, DDL defines the structure, DML manipulates the data, DCL controls user access, TCL manages transaction. Now day comes to database interfaces. Databases interfaces defines how users and application interact with a database. Now, not everyone who uses a database knows how to write complex SQL commands, right? That's where database interfaces come in and they make it easier for users to access and manage data in different ways. The first one is command line interface. Here user type commands directly into a terminal and command prompt. It is a fast and powerful but requires good knowledge of SQL. Next is graphical user interface GUI. This one is more visual and it has windows, buttons, menus and even drag and drop options. Tools like MySQL Workbench are great examples. Then we have form-based interfaces, which shows users simple forms to fill out for entering or viewing the data. It is commonly used in data entry system, for example, filling in a student registration form. And next example is menu-based interfaces. Menu-based interfaces are even simpler. User just pick from a list of menu options. It is often used in ATMs or older management systems. Next example is natural language interfaces are more advanced. They let users type or speak queries in normal human language like asking show me all students from computer science and the system translates that into an SQL query. There are also speech input and output interfaces where users can talk to the system and get spoken responses. Now the next topic is functions of DBA and designer. The database administrator DBA is responsible for the day-to-day operation of the database. The DBA ensures data security, manages backups, and monitors performance. The database designer focuses on how data should be organized, designing tables, relationships, and constraints. Together, they ensure a smooth and secure database management. Next topic is ER model, entities and attributes. The ER model is basically a conceptual model that helps us to design a database before actually creating it. It shows the logical structure of a database. That means it helps to understand what kind of data we will store, what the main objects are, and how they are related to each other. Let's start with the first part, entity. An entity is simply an object from the real world that we want to store information about. For example, it could be a student, a course, and a company. In the AI diagram, entities are usually represented by the rectangles. There are two types of entities, a strong entity and weak entity. Strong entity which can be uniquely identified by its own attributes. For example, a student with a roll number and weak entity is which depends on another entity for its identifications. Now we have attributes. There are they are the details and the properties that describes the entity. For example, a for a student table, the attributes could be student ID, name, and email ID. Attributes are shown as ovals connected to the entity in the AR diagram. Attributes can be of different types like key attribute, composite attribute, multiple attribute, and drive attributes. In key attribute, uniquely identified each entity like roll number for a student, and it is usually underlined in the diagram. A composite attribute can be broken into smaller parts. For example, address can include street, city, and zip code. And third is multi-valued. A attribute can have more than one value, like a student having multiple phone numbers. This is shown by a double oval. And drive attribute is one that can be calculated from another, like age can be derived from date of birth and it is shown as stretched oval. These are the details and properties that describes an entity. For example, student attributes could be student ID, email attributes, and email. Attributes are shown as ovals connected to the entity in the ER model. Finally we have relationships. A relationship shows how two or more entities are connected. For instance, a student enrolls in a course or an employee works for a company. In an ER diagram, relationships are represented by diamonds connecting the entities. And the relationship is one to one to many, many to one, and many to many. A student one-to-one example is a student has one ID card, and one-to-many is one teacher teaches many students. In many-to-one can many students belong to one department, and many-to-many students enroll in many courses, and courses have many students. In short, the ER model helps us to design a clear picture of the database by identifying the entities and attributes and the relationship between them. If it is the foundation step before we actually build the database. Now, next is symbols used in ER model. The different symbols used in the ER model and what each one represents, we will discuss it. And these symbols make it easily to understand the structure and meaning of the database design. First, we have the rectangle. It is used to represent entities in the ER model. For example, a student or a course would be shown inside a rectangle. Next is ellipse. Ellipse represent attributes. These are the properties of entities like name, roll number, address. You will usually see ellipse connected to their entity boxes. Then comes to diamond shape. These represent relationship between entities. For instance, a diamond label and rows might connect the student and the course entities. The line connects attributes to entities and entities to relationships, showing how everything is linked in the diagram. Next is double ellipse. Double ellipse represents a multi-value attributes. That means an attribute that can have more than one value. For example, a student can have multiple phone numbers, so phone number would be shown using a double ellipse. And finally, a double rectangle represents a weak entity. A weak entity depends on another entity for the identification. So these are the main symbols used in the ER diagrams, and rectangle for entities, ellipse for attributes, diamond for relationships, and a few special space for unique cases like multi-value or weak entities. Now next topic is ER diagram. ER diagram that shows two entities, student and college, and their relationship. Here the relationship between a student and college is a many to one relationship. That means many students can belong to one college, but a student cannot study in more than one college at the same time. So the student one side is student entity and one side is college entity. Student entity has attribute student ID, student name, student address, and this describes each student. The college entities has attributes like college ID, college name, which describe each college. In simple terms, one college can have several students, but each student is enrolled in one college. That's why we call this is a many to one relationship. Next topic is generalization, aggregation, and specialization. There are advanced concepts in the ER model. Generalization combines similar entities into one general entity. And specialization divides an entity into sub-entities with specific attributes. Aggregation means it represents relationship between relationships. This concept helps in building more flexible and detailed data models. Now next topic is transforming ER diagram into tables. Once we create an ER diagram, we can convert it into database tables. Each entity becomes a table, attributes becomes columns, and relationships are represented through foreign keys. This process ensures a well-structured, normalized database design that avoids redundancies. Now the next topic is storage structures. Database store data permanently on secondary storage devices like hard disks or SSDs. Dbms organizes these data in blocks and pages for efficient access. Proper storage and management ensures fast retrieval and long-term data safety. Next topic is hashing and indexing structures. To improve performance, Dbms uses hashing and indexing. Hashing converts keys into addresses for direct access. Indexing creates a list that helps find data quickly, just like an index in a book. Single level indexes work for small databases, and while multi level indexes are used for large ones. Thank you.